In this video, we are going to cover the second part of similar polygons. So just to review, similar figures are exactly the same shape, but they can be bigger or smaller than each other. So that means same shape, but different sides. Therefore, the sides are proportional and the angles are equal. This little squiggly line here is what we use to denote similar. So this says it's similar, no line underneath or anything, just a little squiggly line. Okay. And when we say that sides are proportional, what that means is that one side over the corresponding side is equal to one side over that corresponding side. So if I had 10 over 5 equals 6 over 3, that would be correct because 10 over 5 is 2 and 6 over 3 is 2. So a few properties here. The means extremes property states that you can cross multiply using the means and the extremes of a proportion and the product will equal each other. So for a little bit of review, remember the means are the two outsides. So if we wrote it this way, the means are the outside. So A and D and the extremes are the outside and the means are the middle numbers. Okay, so here we have A and D, those are our extremes, and then B and C are our means. So what that says is that we can cross multiply these two and AD will equal BC. Okay, so given a number right here, right, like say I had 2/3 equals 10 over 15. If I were to cross multiply these, 15 times 2 is 30 and 10 times 3 is 30, which is true. The reciprocal property states that if two ratios are equal to each other, then their reciprocals, the ratios turned upside down, are also equal to each other. So what that's saying is that given that A over B equals C over D, we could also say that B over A equals D over C. So for example, just like that last one, the last example that I had there, 2/3 equals 10 over 15, we could also say that 3 over 2 equals 15 over 10. And that makes sense, right? Because 15 over 10 reduces down, right? 3 times 5 is 15, 2 times 5 is 10. 3 over 2 equals 3 over 2. The exchange property states that if you switch the means of a proportion, then the proportion will still be true, okay? So the means, right, are B and C. So what that's saying is that if we were just to flip-flop these, if we were to say A over C equals B over D, then that would remain true. So for example, here if I have 2 over 3 equals 10 over 15, I can just flip-flop these two. I could say that 2 over 10 equals 3 over 15, okay? And if we were to reduce these, 2 over 10 is 1/5, 3 over 15 is 1/5, so they are still equal to each other. The add 1 property states that if you add 1 to each side of the proportion, then the proportion will still be true, okay? Now, what that doesn't mean is that you're adding just 1 to the top of, it doesn't mean A plus 1 over B, like if we were just going to add the number 1, okay? Although that would work. But how this looks in with variables, okay? Let's say I wanted to add 1 to both sides, okay? Then what you can do here is think about what equals 1, okay? And if we want to make this, remember when we're adding up two fractions, you want the denominator to be the same. So in this case, I want 1 to be B over B so that I can add these two together. And in this case, I want 1 on this side to be D over D. All right, B over B and D over D. So I'm adding the same thing, right? Because these both equal 1. Okay, so now I can rewrite this as A plus B over B equals C plus D over D. All right, so what that looks like, if I have the same thing that I had earlier, right? 2/3 equals 10 over 15. What that means is that I can add 3 to the top, 2 plus 3 over 3, and then 10 plus 15 over 15. All right, and look, I'm adding 1, right? Because 3 over 3 and 15 over 15. I added the same thing to both sides, okay? Even though these were different numbers on the top, right? We added 1. So 2 plus 3 is 5. That's 5 over 3. And 10 plus 15 is 25 over 15. All right. And those are the same, right? 5 times 5 is 25. 3 times 5 is 15. Okay, so for a real quick triangle review, remember that the angles of a triangle add up to 180 degrees, okay? And similar triangle angles are the same, okay? So here, triangles A, B, C, and D, E, F are similar, all right? So if angle A is 40, angle D is 40. If angle B is 70, angle E is 70. So if angle C is 70, angle F is 70. All right. It's not like sides where they're proportional, okay? Angles stay exactly the same. So for example here, given that triangle ABC and DEF are similar, I want to know what is the measure of angle F, okay? So here, D is 28, all right? We don't know what E or F is, right? We want to solve for F. Now, if we look over here, we're given B, which is 71, so we know that E equals 71 as well. So since our property states that a triangle adds up to 180, we want to add 71 plus 28, which is going to give us 99. And then we're going to take 180 and we're going to subtract that from 99, or subtract 99 from 180, and that's going to give us 81. So angle F is going to equal 81 degrees. Okay, in this one, it says the triangle JKL is similar to MNO is similar to PQR. What is the measure of side OM? So, since all three of these triangles are similar, all three of their sides are proportional. Okay, so we look here, we have n over 4. So we want to find out what n is, right? That's the big question. What is n? Now, if we look over here, we have 5 and 3, and then n over 4, and then we don't have anything here. So we can't really use that one. But if we look here, this side is n, so we could go ahead and solve for n on these two triangles and then plug it in over here. So what we could say is that n over 5 equals 6 over 3. Okay, and remember our means extremes property, right, that we can multiply the means and the extremes. So 5 times 6 is 30, and then n times 3 is 3n, right? So we divide by 3, and we get n equals 10. So we know that this side equals 10. So now all we have to do is go over here and plug in the 10 to side OM. So we know that side OM equals 10 over 4. Okay, or we could reduce that down to 5 over 2, okay? And if you think about it, that makes sense, right? Because 10 divided by 2 is 5, and 5 divided by 2 is 5 over 2, or 2.5. In trapezoid, here, trapezoid ABCD is similar to EFGH. I want to find the measure of angle H, okay? So I don't know what this measure is. Now, here, I'm given that F is 88 degrees, which I see that B is 88, right? So we know that all these angles are equal, okay? So I know that this angle is 92 degrees, and I know that this angle is 120 degrees. Now, we have to know, what does a trapezoid's angles add up to, okay? Well, so remember our formula from last semester. If we take 180 times n minus 2, that tells us the sum of the interior angles. So we have 180 times 4 minus 2, which is 180 times 2. So our interior angles have to add up to 360 degrees. So what I want to do now is add up 120 plus 88 plus 92, and that's going to be 300 degrees. And so I'm going to take 360 minus 300, which is 60 degrees. So the measure of angle 8 is 60 degrees. Okay. Here I want to find the measure of side HE. Okay, and it's a G inches. All right, so here I'm given 15 on this side. So 15 over G is going to equal 36 over 3G minus 3. Okay, so my property, remember I can cross multiply, means extremes property. So I have 36G. And then here, remember, I have to distribute. 15 times 3G is 45G. And then 15 times negative 3 is negative 45. So now I want to subtract 45G from both sides. And that's going to give me negative 9G equals a negative 45. Divide by negative 9. And I'm going to get G equals 5. So side HE is going to be 5 inches. Okay. Now side EF is 3G minus 3. So since I already found that G equals 5, I can take that 5 and plug it in. I'm going to go up here. Okay. 3 times 5 minus 3. 3 times 5 is 15. And then 15 minus 3 is 12. So this side EF would be 12 inches. Okay, for this last one, it says quadrilateral DEFG is similar to HIJK. So I want to find the length of DE right here. Okay, so I don't know what DE is, so let's just label it X for now. Okay, so we'll say that X over 8. And then here we want to look at what else we have. We have a 3 and a 12 that are already filled in, so let's use that. So 3 over 12. So our means extremes property, right, we can multiply 12x equals 24. You divide by 12, and x is going to equal 2. So this side is going to equal 2 centimeters. Now it wants to know what side, what would be side GF. So let's look here. We'll say that this unknown side is x. So we'll say x over 7. And we can just use the 3 over 12 again. Is it going to equal 3 over 12? So again, we're going to multiply our means and our extremes. 12 times x is 12x. 7 times 3 is 21. Okay, divide by 12 on each side, and you're going to get x equals, okay, this is 21 over 12, but we can reduce this down to 7 over 4. Okay, so GF is going to be 7 over 4 centimeters. Okay, and then the last one says, what is HK? All right, so again, all right, if we look at we have 2 over here that matches, so now our x is going to be on the bottom. We're going to say 2 over x, and we're just going to continue using that 3 over 12. Okay, multiply our means and our extremes. 12 times 2 is 24. 3 times x is 3x. Divide by 3, and x is going to equal 8. So HK is going to equal 8 centimeters. Okay, and here we want to check our work, right? If we look here, 2 times 4 is 8, right? 3 times 4 is 12. 2 times 4 is 8. And then 7 over 4 times 4 is 7, right? Because look here, 7 over 4 times 7 going to equal 7. Okay, so we know that all of these are correct and the scale factor was 4. And that is the end of Similar Polygons Part 2.